Tomorrow, all sine, cosine, tangent stuff. No hill sass. Don't worry about what was on the first quiz. And I know I haven't given it back yet. I still have to wait till everybody takes it. Okay, so I'm not just holding it hostage for a reason. Sine, cosine, tangent, elevation, depression, and also what we're doing today. Okay, what we do today is on the quiz. That's it. Straight sine, cosine, tangent stuff. Find an angle, find a side, draw your own diagram. And then a problem similar to the two girls playing basketball I just went over earlier. Any questions? There's no. I'm not going to do a data review. I'm not even going to give you a review to do. Right? Homework has a couple review questions on it, but that's about it. All right. I'll be here after school if you guys want to sit down and go over any questions with me. All right. Anything you guys want to ask about the quiz? Because we'll go over homework quickly tomorrow and then take the quiz. Okay, what do you say we get into day 11 then? This should be a quick day, I think, so we'll see. All right away. I don't have side lengths on my triangle. I just have the lowercase x, y, and z. Can you guys in your groups right now just find me what the sine of A is equal to? What's that ratio right now? Sine of A is equal to, what do you got? Sine of A equals, using x, y, and z, let me know what sine of A, angle A equals. You got to write SOHCAHTOA at the top of your paper, write it up. What is sine of A equal to there? Using x, y, and z. All right, what do you got for me? What's the sine of A using x, y, and z? 18, sine of A. Y over z, if you want to know where Adrian got that. Hey, sine, opposite over hypotenuse. Opposite A is side y, hypotenuse is side z, y over z. Questions? A little challenging now. Find me something else that equals y over z. Sine, cosine, tangent. Find me something else that would also result in y over z as a ratio. All right, that's what I'm asking for in the next part. All right, sine, cosine, tangent, and give me an angle. That would also result in y over z being an answer. Okay, go ahead. A little bit more challenging. Discuss in your group if you need it. What else would be equal to y over z? And what are you finding? 22. What else is equal to y over z?
Cosine C.
Cosine C, yeah. Take a look, everyone. Cosine C, that's adjacent over hypotenuse, which would be y over z. Good work. Okay, so let's pick this up right now. We just found out what? That the sine of angle A is exactly equal to the cosine of angle C. So let's take this a step further. Can you figure out, just by looking at the diagram, what relation A and C have? Why are they so special? A and C, what's so special about those two angles? Don't get complicated on me. Angle A and angle C, what's so special about them? Ooh, tougher? A and C, what's so special about them? Anybody think they have something? I just don't want to call it. What's up, Romeo? No. No. Way to try to steal the vocabulary word for today, but no. All right, no. Via?
Both of them would add up to the right angle.
So both of them add up to what?
90 degrees.
Okay, give me a vocabulary term we talked about this year. Two angles that add to 90, Carter? They're complementary. Everyone agrees?
Yeah.
What's so special about angles A and C? They are complementary. So, if two angles are complementary, the sine of one equals the cosine of the other. Grab your calculator for me. Grab your calculator. Ready for the magic to happen now. 13. Where's 13? 13. Callum, can you please give me an angle, Callum, that is less than any angle you want, less than 90?
53.
53? Okay, everyone in their calculator right now, do the sine of 53. Just do the sine of 53 in your calculator. You're going to get a decimal, right? All right, now do the cosine 37. Relax. Do the cosine of 37. And what do you notice? They're equal. Why are they equal? Because what do you know about 53 and 37? Okay, sine and cosine, and we're going to write this officially in a second. Sine and cosine are equal only if what about their angles? Complementary. Let's do this again, just so I drive this home. 24. Romeo, give me an angle of less than 90 again. Cosine, everyone do cosine of 24 in your calculator. Cosine of 24. You get a decimal. Do you think you could find me sine of, what do you think here? Sine of 66. Do the sine of 66. Equal, right? All good? But now, and you don't need to write this down, if I do sine of 10 and cosine of 50, do you think those will be equal? No, why not?
Because they're not complementary.
Okay, sine and cosine only equal when angles add to 90. All right, so let's write this officially here. If angle A and angle B are complementary, if A and B are complementary, the sine of one angle, so we'll say the sine of A is equal to the cosine of the other angle. Biggest thing I want you to get out of this, sine and cosine are only equal to each other if their angles add to 90. That's the only instance. And yes, sine and cosine are what we call cofunctions. Here, ready? Watch this, another piece of magic. How do you say this? This is an abbreviation for what word? One more time. What's this abbreviation for? Say that again. Cosine. All right, yeah, cofunctions. That's these two are, tangent has one too, but you worry about that next year in algebra 2. All right, sine and cosine are cofunctions. They're equal when their angles add to 90. All right, real quick then. Can you guys find me another function that's equal to the cosine of 20? I don't want to know the decimal. Give me another function and an angle that's equal to, has the same value as cosine of 20. So cosine of 20 and what else are going to be equal to each other? 21. Sine of 70. Good. Because their angles add to 90. And if you don't believe us, check us. Check it on your calculator. How about sine of 37 now? Sine of 37 should be the same as Jackson.
Cosine of 53.
53, yep. Now we'll actually see if you understand this or not. That was easy, right? Just subtract 90, flip it. Okay, what about 3 then? X is an angle and x plus 20 is an angle. They're both acute. Sine of x equals cosine of x plus 20, find x. If you're doing this right now, you're not picking up what I'm selling. Okay, if you're just setting them equal to each other, you're not picking up what I'm selling here. Do you see sine and cosine are equal? When's the only time that happens? When I know what about their angles? They add to 90. Not when their angles are equal. When their angles add to 90. That's what I'm trying to get through to you guys. If I see sine and cosine are equal to each other, that tells me their angles had to have been equal to 90. And then now this is pretty easy to solve. Well, you got 2x equals 70, x equals 35. And another reminder, this will be on the quiz tomorrow. I think it's like a question, but it'll be on the quiz. All right, let's see how much we're understanding now. I'll do this one with you, then you can do the other three in your group. I got triangle ABC. Angle C is the right angle. Here's why I'm giving you this information, everybody. If angle C is the right angle, what do you know about angle A and B? Angle A and B are complementary. They have to add to 90 if angle C is the right angle. So think about this. Don't get nuts on me. If the cosine of A is equal to radical 21 over 5, what's got to be the sine of B's value then? Don't get crazy on me here. And why are we grabbing calculators? Why are we grabbing calculators? Hey! What did you just tell me about A and B? They're complementary, right? So what do you know about cosine A and sine B then? Aren't they equal?
Yeah, so it's just radical 21 over 5.
Just exactly. Radical 21 over 5. Those two are equal. Cosine of A and sine of B. If A and B are complementary, which all of you said they were complementary at the beginning, that means they're equal to each other. So whatever if cosine A is, it's the same as sine B. Radical 21 over 5. All right, you're in your groups now. 5, 6, 7. 5, 6, 7. Seven might be a little challenging. We'll go through it though at the end.
Yeah. Because there's some decrease equal 90. Decrease it'll be like
Well, the cosine and sine of it.
Wait.
But I think found out that
Wait,
because yeah, wait.
That's a good question.
but if they're equal, wouldn't that such a increase because they're equal? Since they're
So it
equal, they're
increases.
both.
That's good. Oh yeah, it's sine A, not just the angle, so yeah, we get it.
What do you know about these?
Correct.
Like how they
Big Bird.
takes a little bit of water.
No. I'm not saying the angles. I'm saying the value. This is 5/13. So that's 5/13. So now it's something.
Right, good job.
Now, one goes up, the other's down. I'm not talking about the angle. The angle's still at 90.
Oh, so that's what, that's what I was thinking.
I can't imagine you would have to just do like.
Stay at the same, stay at the same.
No, they just lock it. I can do that.
So,
Why are you not?
sorry.
If I could run that. I think it's been very fun.
All right, ready? Number 5. 5, cosine B is 5/13. Which one also is going to be equal to 5/13 then? 19? 5.
Number 3.
Sine A. Sine A. All right. Number 6 here. I know it's very tempting to set them equal. It's very tempting, but remember, if I'm going to set sine and cosine equal, their angles have to add to 90. Angles are not equal. And then what do we get for the value of x here? 21? 25, yep. And then finally, number 7, little tricky here. Again, I gave you this. You got right triangle at C. What do you know about A and B then if angle C is your right angle? These are complementary. So what? Right now, take a look. What do we know about those two right now? They're equal values, right? Right? They're equal values. So I don't know, 2 and 2. So if sine of A goes up, what's got to happen to the cosine of B? It's got to go up too because they're equal. Make sense? So they're both. This is going to increase. And an easy explanation I saw in a lot of your papers because sine of A equals cosine B. One goes up, the other has to go up because they're equal. Any issues? All right, you guys can start the assignment. I'm done. Okay, you guys know what's on the quiz tomorrow now. Check your answers up on Classroom, please, if you finish early.